Okay, good morning class. So today we're looking at a probability. In probability we got up until your independent formula, no? We did that as well. Did we do the dependent events? No. Alright, so today we're going to look at dependent events. We're reading from this example on page 1 on page 412. So we are told that in this section we look at the situation where the probability of one event is dependent on the outcome of another event. For example, if a card is drawn from a pack of cards and not returned to the pack. So in a normal pack of playing cards, how many cards are there? 52. So if you draw a card from that pack of playing cards, and that card is not replaced on your second draw, how many cards do you have an option of drawing from? 51 cards. Can you see that? So that's an example of dependent events. Okay. So the second event is dependent on the outcome of the first event. For example, okay, we read that. Then the probability for the next card drawn are altered. The next cards drawn is altered. Now we look at example 1, and it's on page 412. We are told that a bag contains 9 balls. 5 are white and the rest are black. So if it contains 9 balls, 5 which is white balls, then the rest is black. How many black balls are there? Sorry? If 5 is white, how many black balls are there? 4. So they must add up to 9 in total, no? So the question says, calculate the probability in the first case that both balls taken out of the bag are black. Both balls taken out is black. Now, you don't have to draw a tree diagram, but your tree diagram is going to be the best or the easiest way to do this calculation. A tree diagram. Okay. So what we do is we say, okay, because the outcomes we're looking at taking out, in this case, so say the first ball drawn is a black ball. What's the probability of drawing a black ball on your first draw? It's 4 out of 9 balls. Not so. Then what's your probability for white balls? 5 out of 9. Not so. Now what if my first ball drawn, remember this ball is not replaced. If the first ball drawn is black, what is the probability of you drawing a black ball again? No, it can't be 4. It will be 3 out of 8. What says 1 less a black ball and 1 less ball in the bag. But what is the probability if you had drawn a black ball first? What's the probability of the white ball on your second draw? 5 out of? Okay, you guys understand? Shouldn't I write it a bit bigger? There's black and white. We said for black is 4 out of 9. And the white is 4 out of 9. So the black and white. The black we said is going to be 3 out of 8. And white is? White is 5, no? So it's 5 out of 8. If the first ball was white, what's the probability on you drawing a black ball? 4 out of 8. And white? 4. Do you guys understand? So what is my possible outcomes? Could be 2 black, a black and a white, first a white and a black, then a white and a white. Those are the outcomes that you could have gotten from that scenario. Okay. So, but the question says both balls taken out of the bag are black. So both balls being black, so it's going to be the probability of the first ball being black. And what's the probability of the first ball being black? 4 out of 9. Times the probability of the second ball being black, which is 3 out of 8. It's 4 out of 9 times 3 out of 8. Okay. So it's 4 out of 9 times 3 over 8. 1 out of 6. 1 out of 6. Okay? You guys understand? Okay. You can change that to decimal or you can do it percentage, doesn't matter. Okay. Let's look at number 2 for B in this case. Only one of the balls taken out will be black. Only one of the balls taken out will be black. So what are my options there? Could be the probability of only one of the balls taken out will be black. So we can be black white or white black. You all understand? No? Only one of the balls taken out will be black. So it can be the probability of black, then white, plus the probability of white, then black. You all agree with that? So what would this be? The probability of black is 4 out of 9 times the probability of white, 5 out of 8, plus the probability of white. What's the probability of white? 5 over 9 times the probability of black, 4 over 8. Then the calculator is 4 over 9 times 5 over 8 plus 5 over 9 times 4 over 8. Give you 5 over 9. Okay, do you guys understand? Any confusion here? Any confusion? No? You want to watch the full lesson? In the description box there will be a link. You can follow that link. It will give you. It will take you to the full lesson. Okay. So let's look at C. In C, at least one of the balls taken out will be black. At least one of the balls is going to be black. Now there's 2 ways of doing this. I'm going to do both ways to show you the importance of understanding the shorter method. So maybe you'll start appreciating that method. At least one of the balls taken out will be black. So it could be black, not so. Black, white, white, black. You all agree with that? So this simply can be the probability of black, black, plus the probability of black, white, plus the probability of white, black. We've worked this out already. There's going to be 4 over 9 times 3 over 8, which is 1 over 6, plus 5 over 9 times 5 over 8, plus 5 over 9. Sorry, this is 4 over 9 here, no? Times 4 over 8. So that gives us 5 over 9 plus 1 over 6, which is 13 over 18. Now, if you hadn't done these two calculations prior to that, you should have said 4 over 9 times 3 over 8 plus 4 over 9 times 5 over 8 plus 5 over 9, oops, 4 over 9 times 5 over 8 plus 5 over 9 times 4 over 8. Give you 13 over 18. Okay, can you see that, people? But now, what you notice here, we notice that that is the only one in this calculation that's not accounted for, which is no white, no black, sorry. So the same as saying the probability of at least one black, which is the same as saying 1 minus the probability of no black, which is white. And this is what we call the what? Complementary rule. We discussed that in the last lesson. So there's going to be 1 minus the probability of white. So if we follow that branches, it would be 1 minus 5 over 9 times 4 over 8. Which will simply give us 1 minus 5 over 9 times 4 over 8. That gives us 13 over 18. Okay. So instead of doing this long calculation here, we could have just used the complementary rule. Okay, and the complementary rule says that we add the two subsets, it gives you an answer of 1. Okay. So with that, you should be able to do exercise 12.5. Okay. Stop the video at this point.